Hey, welcome back. This channel just cracked the mark of 100,000 subscribers, and I want to say thank you to all of you. All the subscribers, all the regular commenters, and the non-regular commenters, of course. The Patreon supporters, people who send me emails. I'm bad at answering emails, I know. That's a problem. All I can say is thank you. This channel would not be what it is without the constant growth of the channel, of the viewership, of the engagement I get from all of you. This gives a lot of motivation if you see that the content that you put out resonates with the people, especially since I fill such a niche in the YouTube machining content world. There are other people like, for example, Cutting Edge Engineering, Curtis and Karen, who fill, for example, the heavy machining and large equipment repair role. And that's super interesting content, very different from what I do. I feel like it's more approachable. Everybody has seen an excavator or a bulldozer and a hydraulic ram. And I think especially people who also wrench on cars resonate a lot with the content that Curtis and his wife put out. On the other hand, you have somebody like Quinn, Blondie Hacks, who holds the flag up for the model engineering world. Very, very detailed build logs of steam engines and now the A3 switcher steam engine, steam locomotive, and also very detailed shop project build. So that resonates very well with people. If you look at the subscriber counts of those two channels, that's still completely different from my own channel. I know that I'm filling a niche with what I do. It's kind of esoteric, but that's how I like to operate here. Especially since I run this shop now full-time, at least for this year. Current status is it's running very well. It's working out to make a living out of, I think the shop is 30 square meters with a bunch of machines crammed in here. And so far it's working out very well. I cannot show, that's an ongoing problem. I have either a time crunch on the parts, so filming and photography is a little bit of a problem, or it's NDA parts, especially if it's R&D work or Science-y customers. But I try to film and share as much as possible and as much as I'm allowed. Also, there are shop projects are coming back. Since I have a little bit more time on hand now, doing this full time, there will be shop projects again. I know that a lot of people told me in the comments that they miss the shop build tooling. And honestly, I miss it too. I like to build stuff for myself to try out if I like something, to make things that don't exist or to make things that exist cheaper and better, which never works out, to be honest. It's always more expensive and takes longer than to buy it. That's just the reality. But building stuff is great fun. I can give you a teaser on one of the shop projects that I'm working on. It's an infeed table for my vertical bandsaw. Here is my current shop project. It's my venerable 4x6 bandsaw that I removed everything that made it a horizontal bandsaw. Mine is strictly a vertical bandsaw with a table. But what's this? Well, it's a infeed table. This is basically behaving like a roll-in saw or a Marvel saw, just the saw itself is stationary and the table is moving. People like Mösner sell vertical bandsaws with an infeed table too, for example with servo drive. So what I built here is, a friend of me gave me two NSK linear rails size 12. Here you can see the trucks, there are 4 of them, and the linear rails, they are too long, I need to cut them down still. It's just for proof of concept now. 15mm thick steel plate for the table, ground, and a 70mm tall fence that's square on both sides of the blade. Having the fence on both sides of the blade is important, so when you cut something, it's supported on both sides and just gives a nicer sawing experience. The fence on the back and the saw blade coming through, the idea behind that is to have a central clamp in front here that pushes the work back onto the fence. If you look up Robin Rensetti's roll-in saw, he has shown it numerous times on Instagram for different setups. That's exactly what I'm recreating here. I'm still waiting for the quick acting clamp that pushes up against the fence, but that's details. Definitely video coming on this. I'm working on it. It's built in a way so I can cut, I think, 150mm diameter max. Since the fence is 70mm tall, the real limit is more like 140mm and smaller in diameter, because otherwise the center line of the round material goes over the fence. That's a little bit hard to hold, but 140mm is quite decent. Also, the length of cut is 200mm, and if I need the saw as a regular contour bandsaw, I can just pull out these two screws, and these fences are doweled in. They are aligned with two dowel pins, and you can just pull these off and use it as a regular saw. It has no automatic infeed currently, it's just me pushing here, which is already way nicer than pushing the work over the table. I'm thinking for an automatic feed either very simple gravity feed, big honking wake off the back of the machine with a wire rope, or with a pneumatic cylinder that has an oil dampener added to it. So the idea is you put your work in here, you have your quick acting clamp, boom, pushing up against here, then you can just saw straight through the material. And this allows you to split round material very closely to final thickness, especially if you start out with something that's already a round disc and very thin, and you just put it up with a square so it's vertical, and then you clamp it, and then you can just slice it through the center line, even if it's just 10mm thick. And that's something that I wanted for a very long time, because I like the bandsaw for material removal. Also, another nice thing is you can miter cuts and something like that can be done very easily just by holding the part in an angle. Imagine the clamp coming in from the front, pressing against here. I'm just using the can twist clamp here now for demonstration. Or let's put it on the other side. And that way you can slice up corners or do angle cutouts in material very quickly. And within the height limitations of the bandsaw, cutting straight lines with the length of the bandsaw like this compared to cutting flat on the table like this, this gives you a nicer cut. This gives a straighter cut and just overall a nicer finish that you can cut with less stock for finishing, and also less waste. So that's very beneficial. You can also do flat cuts like this. And of course you can also use it for material removal, like cutting out the corner. So the possibilities with bandsaw are endless. And I think a vertical bandsaw is way more valuable for a shop than a horizontal bandsaw. With a horizontal bandsaw you can just basically only cut off material from a stick. Yes, you have options like bolting things to an angle plate and holding that in a vise, but a vertical bandsaw in my mind gives you way more saw for less footprint. So keep your eyes open for the video on this thing. Will take some time because I'm waiting for the quick action clamp here. And for those who don't know this saw, this is really just the standard 4x6 bandsaw that people like Harbor Freight sell. Harbor Freight org. So for those who don't know this saw, this is basically 4x6 bandsaw that's sold by everybody in the US, Grizzly, Harbor Freight. I took it off the stand, I removed all things not necessary, put it on a stand, made a table for it, and now added this infeed table of course. And I also replaced the original motor and gearbox with an industrial motor and a warm gearbox because the old one died on me. That's the bandsaw infeed table. I also did some recreational purchases for the Deckel FP1 tool room milling machine. It's to be honest, it's two pieces of equipment that I do not really need, but that I really wanted. One is the 40 taper high-speed head that runs 6,000 RPM, and the other one is a XY compound slide that fits on top of the indexing head, and that's used to machine multiple radii on top of the indexing head. And there is a famous palm green XY rotary table. Adam Savage recently showed this thing on Tested, and they built it the wrong way around. They have the XY table and the rotary table on top, and that doesn't make really sense in a combination sense. That's a rotary table and an XY table. But if you do it the other way around, if you have a rotary and an XY table on top, you can use the XY table on top to shift around the center of rotation of your workpiece. I will show that to you in a second on the real deal. But be aware of those palm green tables. They are kind of obscure and nobody really seems to know what they're made for. This will be a quick one because I need to tear it down first. I need to fix a few things on it. But this is one of my recreational purchases for the Deckel FP1 milling machine. This was more a want-have than a I need. This is a 40 taper high-speed head running up to 6,000 RPM. It has a separate motor and a belt drive for the spindle. So compared to the mill itself with its main spindle, these are rather quiet because there's only a 3-phase motor. I think it's 0.5 kilowatts, 0.75 kilowatt. So quite the monster. Not really. Belt drive and the spindle. The spindle is different. Is a different design. It has just like the mill. It looks the same like the milling machine. It also has a quill with 16 millimeters travel, 40 taper internal, so it takes the regular tooling from my mill. But the Deckel FP1 main spindle, the geared head, is needle bearing, and this one is angular contact bearing. So these run a little bit smoother. They cannot take as much load as the needle bearing head, but they are a little bit, well, smoother. But as you can see, it's very grimy. It needs a little bit of love. The dial here has some rust on it. Well, could also be just caked on dirt. I think I'm going to take the quill apart, or the spindle, because the bearings sound a little bit dry. I hope there is nothing wrong with them. So that's the high-speed head. I'm running out of places where to put accessories for the milling machine. Down here I have the XY table that goes on top of the indexing head, and I have a short video section on the usage of this thing. Not a detailed view yet, but you will get an idea what this is for. So let's have a look. I got a quiz for you. What does a 1,000-kilometer road trip, meeting some friends that you only know from the internet, a one-night stay in an artist's Airbnb give you? Well, some accessories for the Deckel FP1 tool room milling machine. We got faceplate. Both of these accessories fit the indexing head. I have an original faceplate, which is 300 millimeter in diameter. This almost acts like a mill table. You use this just like on the lathe. You use strap clamps or C-clamps, can-twist clamps to hold work to it. And if you're a little bit of a savage, you can also drill and tap holes into it as needed. A lot of people do that, and most of the used faceplates, well, they look like that. This one is in excellent condition. It only has these 4 drill marks where somebody drilled a hole circle slightly too deep. But at least after 4 holes they noticed it. Apart from that, it's just a little bit dinged up. Should be fine after a light stoning. And all these accessories have the interface cylindrical register with the 4 set screws that directly goes onto the face of the indexing head. I was very skeptical about this interface, but this is really rock solid and surprisingly repeating. This thing is bloody heavy, but this thing is even more so. This is basically a solid chunk of iron. What's this? Well, it's heavy. It has the same interface that goes on to the indexing head on the back side. And then it's basically a cross slide. It has an x-axis and a y-axis, graduated in 10 micron increments on the dials here, very nicely made. Has engraved scales on here and a adjustable 0-point marker. So what's it used for? This belongs to the punch milling accessory or the punch milling system. You use this on the indexing head, you put your part on top of it, and when you want to mill radii, you always need to put the center of the radii that you want to mill on center with the axis of the indexing head. Normally you do that by tapping the work around and indexing it in with dial indicator. This makes it a little bit easier, especially if you have more than one radius to machine, because you can just offset the part in its setup without resetting it up and move it to its new center location, machine the radius. Then you can shift to the next radius, and that way you can machine quite complicated geometries on a manual milling machine using a rotary table without having to reset up for every single radii. I will put this on a milling machine and we will see how this works out. Okay, let's quickly look into the manual of the Deckel FP4M. This has to be the nicest illustrated machine tool manual ever. They had these extremely nice hand-drawn pencil sketches for everything in regards of the machine. And here is the compound chuck. That's what they called it. Use of the attachments, number 7, compound chuck. And yes, this is for the Deckel M, which is a substantial larger machine, but the idea is the same. So it's used in conjunction with the index head for machining contours composed of straight lines and circular arcs. And that's exactly what it is. It's a very fitting description. Here you can see it up against the apron with the indexing head. The indexing head is the same as on the Deckel FP1. They used it up to the size 4 machines. And you just put it on the indexing head, have your back paint treated, and then you can use it to machine items. Here they go into detail how you lock it to the spindle nose with the 4 screws. Operation of the locks of the dovetails. Work holding. You can also mount, for example, a 3-jaw chuck, or you can use flanges and bolt parts directly to it. Quick word about lubrication. It just needs to be cleaned and oiled regularly. So it's a very simple item. There are other things too, spiral milling attachment, which is a fairly complicated item to operate. There is the FP4 high-speed head, which is a little bit different. This one already has a spindle lock. It has a spindle lock to lock the spindle on the push of a button, which my high-speed head doesn't have. So changing tools on these is always a little bit painful. You can't put them in low gear to lock the spindle either. Yeah. The FP4 also had a double swiveling angle head to mill compound angles. So this manual, it shows up on the internet. It's really interesting. It's quite interesting to see what's possible and to see some of the accessories that you rarely see on the internet. Slotting head, precision boring head. I think they even show the grinding head. Yeah, this is the micro drilling attachment. This goes onto the end of the quill to drill from 0.15 to 1.5 millimeter holes using gravity feed. You balance it out with those 2 weights, and then you can just drill with, and then you offset one of the weights a little bit, and then you can just drill with gravity feed. This was pretty nice on the Deckel FP M and NC machines, on the controlled machines. There's a chip pan that hooks up to the apron and kept the mass to a reasonable level, but still allowed you to access the milling machine completely all the way around. If you run flood coolant, it's a pain because you spray the entire surrounding of the machine. Since the sliding chuck is so heavy, it's a little bit tricky to get it onto the indexing head. I tried it by hand, but lifting it on top of the cylindrical register boss of the indexing head and getting it into alignment is quite tough. So using the overhead crane makes it way simpler. And my lifting eye attachment that I use for the rigid table of the mill also fits the T-slot of this sliding XY chuck. Once it is in place, you just tighten the 4 set screws that engage into matching dimples in the nose of the indexing head, and they are positioned in a way so that they pull down the item that you mount on the indexing head face. They contact at the sides of the dimples that are drilled into the spindle. And in ideal case, you tighten them crossover opposite sides and then 90 degrees the same, just like you would tighten wheel nuts on a car. As you can see, the thing sits on the indexing head. I put one of the self-centering vices on top of it. The T-slot plate here is shop made. That did not come with the XY chuck. Deckel called it a Verschiebefutter, which means literally a sliding chuck. What it really is an XY cross table. And it just had a few threaded holes in the top plate, but somebody at the former place this thing lived in made this T-slot plate with the 45-degree offset T-slots. It looks nice, but I'm not the biggest fan of the 45-degree T-slots. Not so sure about that. But with the self-centering vise on top, it seems to work out. I did a little bit of machining on a piece of aluminium, and I will zoom in a second. And all I can say, this XY slide on top of a rotary axis is a complete mind bender. My head hurts from doing just this simple part without any precision needs. Just to figuring out which axis to move at which time. Ignore the witness marks in the center. This is just really super rough, done with an end mill in one roughing pass. No finishing, no nothing. Just to figure out the geometry that this table creates. So I have two radii on both ends of this contour, and they're connected with a tangent line on each side, and each of them has a central bore. And it's all done in one setup without disturbing the part, which is kind of cool, I have to say. Normally you would set up the part, machine one radius, then maybe cut the tangents if it's angled, like on a crank of a model steam engine. You would cut the tangents if that was the design of the crank, of course, and then you would reset it up and cut the radius on the back. And with this setup you can cut everything in one go, not having to reset. You can use all the measuring instruments that the machine gives you, like the dials on the 3 machine axis, the dials on the XY slide, and the rotary dials on the indexing head, or in my case the digital readout on the machine axis, which makes all this a little bit easier. So let's add some more features. Let's add a radius cutout on both sides, like this. Just eyeball, nothing precision, just to give you an idea of how you operate this. So this is not a manual video or a tutorial. This is an absolute, Stefan tries to figure out a new piece of equipment, which he is absolutely excited about. So for starters, I put the indexing head back in its 0-degree position, because it just makes things easier to figure out. So then we crank the x-axis back to 0, because that's the center of rotation. Well, and also in the y direction. Okay, now we are at the last center position that I used on this contour, which is the center of this rear bore. So to get my center position over to my cutouts that I want to cut, I'm using the x-axis of this cross slide, and I crank it over. And I could use now the dials to exactly find my geometric center. Okay. Now if I went down and if I rotated the part, I would cut a hole in the center of my geometry. Just like this. And then I would use the Y or the X axis to set the diameter of the bore. But in this case we want the bore to be off-centered from the center line of the part. This is a complete mind bender if you're not used to it. My deepest respect to the machinists that had to use these in their daily life and make money using these. So I'm moving over, let's say, 6 millimeters, which gives me kind of the outside contour here. Now I can plunge down and start machining my radius. Okay, cut number 1 on this side. And now I need to go to the other side of my contour. I cannot move the y-axis of the machine, otherwise I would just cut a larger radius. I need to shift the part on the rotary axis of the indexing head. So let's go back to 0 and then 6 millimeters in the other direction. Of course, since we're using dials, we have to consider backlash, so we go over 6 millimeters and then we go back. So here's 0, and we could also lock all the axes, but let's not overcomplicate things. So let's start at 0 again, plunge down, and then we rotate out to our diameter. Okay, yeah, so now we added those two features too, without having to reset up. And that way you can create a whole bunch of machining operations without disturbing the setup. I guess we pushed this back under the lathe until I need it in 5 years. Quick word on bench vises. I think, well, yes, you need a decent bench vise. These days, this is my preference. Hoyer Brockhaus. These are made, these are forged, not cast. They are quite hard to destroy. Yes, you can destroy them if you watch Fireball tools, but in regular shop use, you will have a hard time breaking one of these. You can pick them up on the used market for very little money. The problem with these is they come with serrated jaws, like a flat knurl, and to be honest, that's quite useless for 99% of general shop use, because who likes a nice flat knurl in his work? What I do when I get these vices in, and we did that at work too, we take out the jaws, that's the original flat knurling. Looks like it's done with a large fly cutter at a high feed. We take the jaws, we flip them around, we surface grind them, and you have to resurface grind them from time to time. And we use them that way. With our preference always has been hardened jaws and very smooth. With those, if you keep them clean, you don't leave marks on workpieces. There is nothing I dislike more on a bench vise than those aluminum jaws that you put in to seemingly protect your work. But there are two problems. You will pick up the darn things about 1 million times a day. Second, you will imprint chips like steel chips. Say you cut off a bolt in here with your hacksaw, and over time you will imprint chips into the aluminum jaws, and if you have a soft jaw with aluminum imprinted, it will scratch your nice work again. So kind of defeats the purpose. And thirdly, if you have your aluminum jaws in here, these like an L profile, and you clamp something very, very far on top where the aluminum L profile is not supported on the hard jaws anymore, the soft jaws will always tend to tip. They will tip away from you, and that's mildly annoying. Let's say it that way. So that's my... If I need a real jaw that's not scratching, for example, a black oxide finish, I will put on this stuff. This is powder tape, masking tape, very, very resistant plastic tape, or masking tape, regular blue masking tape. Put it on the jaws, and then you can work on parts without leaving micro scratches on very soft materials or very sensitive parts like black oxide or anodized surfaces. So that's my 5 cents on bench vises for a machine shop. There is also the other style of that's also very common here in Europe, the Boley or linen vises that are cast, where the jaw is moving on the back. Those are also very nice, but they have one drawback. With this style here, with the front moving jaw, you can clamp long parts and have them extend down the bench if you have mounted it far enough to the front of the vise of the bench, of course. With the rear moving jaw, you can do that, only extremely limited. So that's one of the reasons why I changed from the Boley vise that I used to have to the Hoya vise. Picked this up used, cost me like 50 bucks and one drive with the car. Also, I'm usually not, well, there are all these super large and huge vises and people having 17 vises in their machine shop, and I'm not sure why. Maybe it's the kind of work I do. I get very far with a single 100mm wide vise. And if I need a really strong vise, I can always clamp stuff to either my large drill press table or to my milling machine table. That's 500 or 700 kilos of mass that help me to work on stuff. At work we always bolted one of these bending fixtures to bend flat profiles, to flat stock. But we just held that on the milling machine because it was a nice hard point to mount it. Then I have two tools that are really not meant to exist in my shop. One is an Indexable drill. That's kind of blurring the lines. I guess it kind of makes sense even on my machines. And the other one is a diamond Endmill that's made to mill carbide. And let's have a look at those two tools.
And this is a 50 flute diamond Endmill. This is 6mm diameter across, has 50 flutes, and there is a piece of, I think it's polycrystalline diamond, braced to the end of a carbide shank, and then the cutting geometry is formed with laser into the diamond. And this is by no means a cheap tool. This is close to 4 figures. A very generous person sent this over to me. Let's call him the guardian angel of this channel. and I want to fart around with it. Well, I will do minimal farting because, as I said, this is an horrendous expensive tool, and maybe there will be the day where I can use it for something useful apart from doing a 5-minute video here on YouTube. So you see the cutting geometry, and this end mill is made to cut tungsten carbide. And it's made to cut certain ceramics like zirconia. What? You can't machine carbide. Well, you can, and you can for quite some time by now. At my day job we use tooling from 6C to do drilling and thread milling in carbide. A few years ago already. It worked quite well. The thread, when you do thread milling in carbide, they come out beautiful, way nicer than many tapped threads in steel. So we have this end mill, and it is actually cutting, not grinding. So it is a mill, or an end mill. It's completely insane when you look at it. Normally you would use this on a machining center with very controlled cutting conditions. I have 2 machines that can run this end mill. The Sorotex CNC router and the Deckel FP1. The interesting thing about this, as far as I'm no expert at all, you can scale the cutting parameters for these up and, down at least, very far. I'm running this at 2000 RPM on the Deckel mill with 20 millimeters per minute feed. You can calculate the chip per tooth yourself. This was milling carbide with a specialized end mill for cutting carbides and ceramics. As you saw, the cut runs relatively uneventful. The only problem that you have is the fine carbide dust that you're blowing all over the shop, because you have to run these cutters with compressed air, because I suspect they don't like recutting carbide dust or carbide chips with their flutes. And this is a, I think, 50 flute 6mm end mill with a solid diamond end. And the flutes are, I think they're laser cut into the diamond. So this is very wild technology here. But it's approachable if you have like $900 for an end mill. It's approachable. It can be done on normal
CNC machining centers, you don't need necessarily something like a Kern Micro HD or hard cut machine like a Rhodas or a Kitamura or something like that. You can approach this on normal machining centers. They also make drills and thread mills to cut into carbide. And yeah, it's interesting technology. Nothing I will use in general here in my shop. This was just a fun little test with one of those end mills, cutting 6mm wide, 0.5mm deep slot in 5 passes into this piece of carbide. So that's a piece of carbide, 20mm carbide shank, and there is some machine feature on the other end. Somebody did some milling trials on it already. So that's my test cutting carbide. I will put this end mill away and I will keep it until the day I absolutely have no other choice than to use it. But that's probably the first time somebody has cut carbide with a dedicated 50 flute PKD Endmill on a Deckel FP1. Back to my new hobby of putting inappropriate tooling in ancient manual equipment. Here I have an ISCAR 19mm inserted drill. Means it had 2 inserts, one here, one on the other side. And you usually see these on proper industrial CNC equipment, vertical machining centers, horizontal mills, and CNC lathes to remove a lot of stock in a short amount of time. You rarely see them used on manual machines, and I'm not entirely sure why. A toolmaker friend of mine from Liechtenstein used a slightly smaller one. When I visited him, I noticed that he had one of these in a multifix tool holder on his small Schaublin 102 lathe. And he told me it works fine. It works fine. You have to take a little bit more time than on a real 40 or 50 tape VMC, but it works and it's good to remove a lot of stock. So a good friend of mine gave me this ISCAR drill, and I wanted to put it in the MCO lathe, but currently I don't have a reducer sleeve for a 25mm shank to go in a boring bar holder, so I figured I have a 25mm collet for the Deckel FP1, and that's a rigid machine for its size, so let's give it a shot here. Teaser, you can see 2 holes here. It works. And boy does it work. So let's move the table over. I'm using it like a regular drill with the quill, not power feeding, because I currently have absolutely no base of understanding how they behave without high pressure through coolant. Normally these drills are used with through spindle coolant, means there is coolant shooting down from the inside from the spindle through the tool holder, and then there are channels drilled on the inside of the tool and the coolant shoots out the end. I don't have that on the machine obviously because it's ancient, but I have a little squirt bottle, so let's give it a shot. 630 RPM, and this is mild steel. This works way better than it should, in my opinion. These drills, when they break through, they cut out this disc of material, super sharp on the edges. I heard from stories on CNC lathes, open frame tool room lathes, that these will fling out to the side and be a little bit dangerous. But on a mill, this doesn't seem to be a problem. But you heard that the cut is really quiet, and there is not even a hint of chatter, no scratching noises. It's just behaving extremely well. And the pressure on the quill handle, I don't like large twist drills a lot. They seem, without pre-drilling, they always seem to take a lot of force to get them cut nicely. And this cuts really nice compared to a twist drill the same size without pre-drilling. It's not super fast. I think I could push it harder so it breaks the chip, but then I get into problems with coolant, I guess. Usually, disclaimer, I have no real world experience with these on real machines. It's only what I see in videos. But these usually seem to break the chip extremely coarse when you feed them hard enough. They put out small curls of chip. You saw by hand feeding, I create this style of chip that doesn't break, but it comes out the flutes of the drill. So yeah, seems like you can use these on manual equipment, and maybe it's kind of useful. I will keep this drill around. I have a box of inserts for it, so maybe this will find its way into my tooling setup here in the shop, and maybe you see it a little bit more in future. But I'm mighty impressed. I would not have expected this to work as good. Here you can see the finish that the drill leaves. It has a little bit of scoring marks, probably because of the lack of coolant, but overall it's a nice bore. And as for tolerance, these don't seem to be precision tools because it drills undersized, as far as I can tell. On a CNC lathe, I heard that you can use them to drill out a hole and then put them off center and bore out the hole to final size. But I'm not sure if that goes that well with the insert geometry in this tool. We will look at the tool on the bench in a second. I made a sleeve to use the inserted drill over here on the lathe, and well, I'm running out of stock that I can poke holes into. So this is a piece of 303 stainless. This should go fine, running at 600 RPM and hand feeding again. So it works too, but over here on the lathe, it's not as stable as on the Deckel milling machine. The MCO is significant less stiff as the milling machine. That's for sure. That's a weight difference of times 3 almost. The MCO is about 200 and something kilograms, and the Deckel FP1 in its configuration like it's there is more like 700 kilograms. And all the components are just more beefy. It works here on the lathe just as on the milling machine, but I think the lathe is less stiff. Well, it is. I don't need to think. There is a weight difference of about the lathe is about 200 and something kilograms, and the Deckel FP1 is in its configuration like I have it about 700 kilograms. And all the components on the Deckel are just more beefy and just heavier. Spindle bearings on the Deckel are larger diameter. So that's the reason why it doesn't run as smooth over here on the lathe as it does on the milling machine. Despite that, I think this could still be a very valuable tool for what I do, especially for aluminium work. I have to poke. I'm doing a good amount of like this diameter aluminium parts that need a large hole drilled and bored out. And when you do that, normally you need a pre-drill, a little bit larger drill, and then you come in with a boring bar to clear out the material. With this, I can poke a large hole in there with a flat bottom, and then come in with a boring bar right away to remove a lot of material in short order of time. So let's see how it behaves in aluminium, running at 600 RPM too. Well, that's behaving extremely nice. I think I will definitely keep the tool around for purposes like this. Let's see if we can enlarge the hole with this tool right away. Yikes! That wants to sing. Yes, you could use it to enlarge the pre-drilled hole with the boring bar, but since this is a 5 times diameter indexable drill, it wants to sing if you put it off center because it's not a balanced cut on both flutes anymore. So that's possible, but wow, my ears. So that's an option here, and that's the drill in a multi-fix boring bar holder. In there you can see the split sleeve down there to adapt it from the 25mm shank to the 30mm boring bar holder diameter that I'm using. That's this tool. Here's the business end of this indexable drill. And you can see we have one insert. They look like CCMT insert, but they are not. As you can see, it has a similar shape, but there is an additional edge down here. So it's not a CCMT insert, it's a proper proprietary insert, as with most modern insert tooling, unfortunately. But that way they can optimize their inserts for the tooling. At least this drill uses 2 similar inserts and doesn't need one for the external cutting edge and a different one for the internal cutting edge. Both inserts on this cutter are the same. As you can see, this one goes mildly over center and clears the inner portion of the bore, and the other one extends out to the OD of the drill and clears the material on this side. Also, there is a nice built-up edge on this insert from drilling aluminum, but I'm not worried about that. The built-up edge will chip off the second you hit some hard materials again. So that's usually not a big problem with roughing tooling. On a finishing tool, built-up edge can be a problem, of course. So yeah, that's the business end of the indexable drill. And here is the number or the type of drill if you need to know. Mitsubishi TA FL 19 is the diameter, and it has a sleeve on it currently, 30mm OD, so it goes in my boring bar holder. So yeah, very nice tool. We have 2 wildly different tools here. One inserted drill that's kind of a roughing tool, and then we have a carbide milling end mill that's more or less the pinnacle of modern cutting tools. Being able to make something like this on a CNC milling machine. If I had told my dad a few years ago that we were able to mill carbide now, he would be like, you're joking. And now this is a capability that very many shops have these days. I'm in the very privileged situation that I have great friends that gave these 2 tools to me. This is a little bit more reasonable in my shop. This is something approachable, but this is so much out of my wheelhouse normally. I would never purchase something like this. The indexable drill maybe, but I can see myself integrate the indexable drill into my workflow just to poke large holes as starter holes for boring bars, since I have a very strong dislike for large twist drills. Not entirely sure why, but I just don't like them. And this might be a solution for that. The 56 flute diamond carbide end mill diamond carbide milling, end mill, will not find its way into my regular workflow because I'm not set up for it. I don't have the right CNC mill for doing carbide milling, and yeah, there are shops with real CNC machines that do this kind of work. But it's neat to see what's possible. So you made it to the end of this video. One question that I have to you, the viewership: would a live stream be interesting for you? Would you? This wouldn't take away any of the content that I create regularly. It would just be another thing. I don't, not scripted out, not planned. Just me turning on the camera, monitoring the chat, and having kind of a discussion, talking about things. You could ask things about the shop, things like that. Just would that be of interest? And how to schedule it. There is a thing called time zones, and that's a problem because the viewers are all over the world, and I would have to find a point in time that makes sense for a large-ish number of viewers. That's something I'm thinking about. Came to my mind, and maybe I will do a live stream from time to time. Not on a regular basis, not to take away any of my regular content, just as a little bit of a, well, another way to interact. The interaction is always a bit, if I answer an email, I help one person. If I answer a question in a comment, I might help a bunch of people, and that's this progression of sharing knowledge. How many people can you help out with a certain amount of effort? And the wider the bandwidth of people to reach with a certain type of media differs. So maybe that's something that's of interest. So thank you all for watching. Thanks for the support. I highly appreciate it. Let's go to 500,000 subscribers next. Thank you all for watching, and I'll be back.